Hello, in this lesson we're going to be factoring polynomials. And I think from the beginning I'm just going to warn you that this is a pretty lengthy section. It's going to require several long videos. So again, decide where you need to take a brain break. Okay. All right, factoring polynomials. Okay, I'm going to make an easy example out of what we're doing. Of course, our work isn't going to be that easy, but I just want to kind of put the math to what we're doing. We're going to be factoring polynomials, but what if we had the number 15 and we were asked to factor 15. Factoring means that you're going to break 15 into a multiplication problem. So I can make 15 5 times 3. And I'm going to go ahead and use parentheses because that indicates implied multiplication. 15's other set of factors would be 15 and 1. And you can use the multiplication sign, but for the purposes of what we're doing today, I think it's best if I use the parentheses to indicate multiplication. So we're not going to be factoring numbers, we're going to be factoring polynomials. And in an earlier lesson, we saw the structure of what it took for an expression to be a polynomial. All right, so for factoring polynomials, the first thing we always want to look for is a common factor, the greatest common factor, specifically the GCF. And it's composed of the largest number and the variable that you can divide out of each term. So for the first example here, for this polynomial, we have two terms. Remember, terms are what you add and subtract. So 4x cubed is our first term and negative 2x is our second term. That's subtraction, but I do apply that as a negative sign, and so I'll say it that way. Okay. All right, so we're going to look for the GCF. The description here says examine numbers first, then examine variables. Okay. Well, the coefficient of this first term is 4 and the coefficient of the second term is 2. 4 and 2 both have a common factor of 2. So I know I can divide 2 out of 4 and 2 out of 2. All right, now let's examine the variables. I have an x cubed and I have an x to the first power here. Both of these terms at least have an x to the first power. So what we've done is we've just found our GCF. We know 2 divides out of 4 and 2, and we know x will divide out of x cubed and x to the first. So we found our GCF. We're going to divide it out. And then because we're making a multiplication problem, remember we're factoring, which means make a multiplication problem. Okay, I'm going to go ahead and put this in this parenthesis here, which is implied multiplication. All right, easiest thing for me is I think, okay, I'm going to divide out 2x from 4x cubed. So what do I have to put here so that when I distribute 2x in, I produce 4x cubed? If you want to think about, well, what has to be present here so that when I multiply, I get 4x cubed? Well, I'm going to have a 2 here, and what can I multiply x by that I'm going to put here that gives me x cubed? And that's going to be x squared. Along the way, I always just kind of encourage you to check your work. Okay, by distributing back in 2x, we will get back to 4x cubed, which was what it was in the original problem. All right, so we have a subtraction sign here, so I'm going to put that down next. Okay. 2 divides out of 2, leaving 1. X divides out of itself, leaving 1. So I do need to put a 1 here. So another way to think about this is, what do I multiply 2x by that goes here that gets me back to this term? Okay. Now, I have to kind of investigate what's happening inside the parentheses here. Can this quantity, this binomial, be factored further? Well, it can be, but we're not going to worry with that because it actually factors into some irrational numbers, and we want to just stick with nice rational numbers for our coefficients. So we took out the GCF and we're finished. Okay, if you want to attempt these next 3, I would encourage you to turn the video off and then come back and just check your work. You could probably go through it a lot faster than I can explain it. Okay, for the second example, I'm studying the numbers first. So 3 and 6 have a common factor of 3. I'll record that. Now move on to any common variables that they have. Well, x squared and x, I can divide out x to the first from both of these terms. So I've just created my GCF. It's a multiplication problem because that's what factoring means. What do you multiply 3x by to get 3x squared? Well, 3 divides out of 3 one time. I don't need to show it. What can I put here so when I multiply x to the first by this term, I'll get back to x squared? Well, that's another x. Check your work along the way, making sure you don't make errors. Sometimes I catch myself if I check my work. All right, and 3x divides out of 6x, leaving 2. Close your parentheses, we're finished. Double check your work by distributing back in your 3x to see that you do get back to what you started with. So we're just taking out GCFs. For this example, 18 and 27 both share a common factor of 9. 9 divides out of 18 and 9 divides out of 27. Now 3 of course will divide into 18 and 27, but 3 is smaller than 9. And remember, we're looking for the greatest common factor. So, and because this term doesn't have a variable with it, I can't divide out a variable. The most I can do is take out a 9. All right, what goes in this position right here? So when I multiply by it, I get back to 18x, so that's 2x. And then we have a plus sign, an addition sign, and then 9 divides out of 27 3 times. All right, and you try this one on your own and then come back and check. It appears that 9 divides out of each of these numbers, and then when I look at the variables, I have x to the 4th, x to the 3rd, and x squared. So I know at least in each and every one of these terms, I can divide out an x squared. So I'm going to go ahead and pull out x squared, make it a multiplication problem, and think about, what do I multiply 9x squared to get back to 9x to the 4th? Well, that's going to be an x squared here. I have a subtraction sign. 9 divides out of 18 twice. X squared divides out of x cubed, leaving just x to the 1st. 9 divides out of 27 3 times, and x squared divides out of x squared by 1, so I just need the 3 there. And again, double check by multiplying 9x squared back into all terms in this trinomial. Okay, I started off with the first one saying we need to look at the behavior of what's happening inside this parentheses to see if it factors further. This does factor, but not the way that what we're interested in this course. More about that later as we continue through this lesson. X plus 2 does not factor any further. 2x plus 3 does not factor any further. I'm a little bit interested about whether this trinomial inside this set of parentheses, trinomial means 3 terms, I'm a little bit interested to see if this would factor. We're going to connect back to this later in the video. So, but right now for what we're doing, taking out a GCF, we're finished. All right, we're going to continue factoring polynomials. Okay, we always want to look for a GCF first, and then from there, we want to investigate what's left in the parentheses and can that be factored further. Right here, we were just focusing on taking out GCFs. But now let's turn our attention to factoring quadratic trinomials. Well, I know the word factoring means make into a multiplication problem. Quadratic, that might be a new term to you. That means that we have a polynomial that's of the 2nd degree. That means that the largest exponent on any of the variables is a 2, 2nd degree. And trinomial means 3 terms. And we can see right here that we have 3 terms. Terms are what you add or subtract. Now, keep in mind that A is representing the coefficient on the x squared term, and A is representing the coefficient on the x term, and C is your constant. A, B, and C are all numbers. These 2 are coefficients, and this number without a variable is a constant. Okay. All right, we're going to factor quadratic trinomials. Okay, and these are the rules to remember. There's a lot of them. I'm not going to go through each of these rules on the front end. What I would suggest is let's go through a few problems together. And then after we go through the problems together, I would suggest and recommend that you go back and read through these rules to remember to think about, did we do that in the problems, the examples that we solved? I think if we started to read this, it'd be too overwhelming and you'd check out real quick. I know I would. I just want to get right into the problems. Okay. All right, so we're factoring quadratic trinomials. Okay, so we're going to be looking at an easy case. And the easy case of factoring a quadratic trinomial is when specifically the coefficient, the a value on the x squared term is 1. So if this number right here, this coefficient is 1, which it won't show up, we don't write that understood 1 there. If you just had x squared plus and you had 2 other terms, that's what this next group of problems is going to focus on, is that easy case first. Okay, so for the easy case of factoring when a is 1, we have to find 2 numbers that multiply to equal the constant term. But they also have to add up, those 2 numbers, those 2 factors have to add up to equal the value of b, the coefficient on the what we call the linear term. linear term, I may have mentioned it earlier, is when the highest exponent is 1. So we got to find two numbers that multiply and give us c, but then they have to add up to equal the b value. When a is 1, this is the approach we took. All right, so here we have an example. Okay, and it's already worked out, but I'll kind of guide us through it, and then we'll have some of our own to work through. Okay, if we want to factor this quadratic trinomial, degree 2, 3 terms, because a is 1, a's value is 1, this is going to be an easy factor. Okay, I might suggest when we're doing factoring that you write out and have a visual in front of you the values for a, b, and c. So a is 1, b is 5, and the constant c, the number without the variable, is 6. All right, so we're going to find two numbers that multiply and give us 6 but add to 5. So we're going to create a factor sum chart. So for this case, two numbers that multiply and give us 6. So we want to find factors of 6. And remember, we got that 6 value from just the constant right here, which is 6. But really, if you were to multiply a times c, and I'm going to go ahead and put that here. A is always 1 in this case. So when you multiply 1 times that constant, you still get that same constant. Okay, you're going to find factors of 6 that sum to b. So what is b? Well, b is 5. So when we create our own factor sum chart, I would suggest labeling it AC and then b and factor and sum. All right, we already found the factors of 6. 1 and 6. Another set of factors would be 2 and 3. That's it. So once we find the factors of 6, let's find the pair of factors that add to 5. Well, 1 and 6 make 7, 2 and 3 make 5. So this is not the set of factors we're going to use. This is the set of factors we're going to work off of, 2 and 3. All right, so let's come back over here. We're going to factor this, which means we're going to break it into a multiplication problem. Well, let's look at x squared. X squared can be found by multiplying an x times an x. So notice you have two binomials. And when we use the FOIL method or the distributing method, if you were to multiply x times x, we're going to get to x squared. Okay, so we do know that. We found our set of factors that multiply and give us 6 that add to 5. Then all that's left in this easy case is to fill in these spots right here with these factors. So I filled in a 2 here and a 3 here. Now, would it have been okay to put x plus 3 and x plus 2 and just switch the 2 and 3? Yeah, it would be. If you were to FOIL these together or FOIL these two together, you're going to get, after you clean it up, you're still going to get the same answer. And that answer happens to be the problem we were trying to factor. Okay, so let's go on and look at another example. All right, we have to factor this quadratic trinomial. Yep, highest degree is 2. That's what quadratic means, and yeah, there's 3 terms. Okay, let's create a factor sum chart. Okay, we want to find factors of the constant, which is 6. And remember, we can get 6 by multiplying a times c. So this is the product a times c. Oh, and I meant to put over here, let's go ahead and record the values for a, b, and c. So a is 1, b is -7. Take the subtraction sign as a negative, and c is 6. So we want to find factors of this product, and we want to find that they sum to -7. Okay, so I would start with factors of 6. Now, I'm going to have to add these factors together, so to get a positive 6, I can multiply 2 positive numbers or 2 negative numbers together to get that positive 6. And because I have to add my 2 numbers and get a negative b value, I'm going to record negative factors. So factors of 6 are 1 and 6, but let's make them both negative. Factors of 6 can also be -2 and -3. Okay, now let's sum these numbers, these factors. The sum of these two numbers is -7. So this is going to be a set of numbers I'm going to use. Okay, the sum of these two numbers is -5. So this is not the set of factors I'm going to use. If I'm going to factor this, I build 2 binomials, and up front I'll put x and x. And then all I have to do is I have to slide these numbers in these positions right here. So I've already got the minus here, so we could just fill in 2 and 3. Oh, but pardon me, we can fill in, oh my goodness, we can just fill in the numbers, not 2 and 3. we're going to fill in the numbers 1 and 6. So x minus 1, x minus 6. If you were to check your work by foiling, okay, you should see that we're going to get back to the original problem. Okay, and I encourage you to foil to make certain that that does check. All right, and we have one more example here, and then we have a few that we're going to try on our own. Okay, number 5. Let's factor. All right, this is an easy quadratic trinomial because a is 1. If you got the hang of this, I would turn this video off and attempt this on your own. Okay, it should be an easy factor because a is 1, b is positive 1, and c is negative 20. I know I can go ahead and get started on my answer by building 2 parentheses and putting x and x up front because they will multiply and give me x squared. I'm going to build a factor sum chart. So I need factors of the product a times c, so that's going to be negative 20. And I need those factors to sum to 1, which is our b. I think I need to label that b up there too. All right, so we need a product that's negative. So how do you multiply two numbers to get, what types of numbers do you multiply together to get a negative answer? Well, you can't multiply positive times positive, that's not going to give you negative. And a negative times a negative is going to give you a positive. So it looks like one of my factors is going to have to be negative and the other positive. I wouldn't worry about the signs just yet. I would actually just think about what are the factors of 20 and then make the adjustment to one of these factors here to make one of them negative to help us get what we want. So factors of 20 are 1 and 20. Now if I sum these, I'm going to get, if I had just 1, I'd get 21, but I need to make one of these numbers negative. Because the sum is positive, the bigger number has to be the positive factor. So I would put a negative on the 1 here. Well, that sum is 19, so that's not going to be the set of factors I want over here. The next number that divides into 20, remember I'm kind of disregarding the negative right now. I'll adjust with that later. 2 divides into 20 10 times, so think about the factors 2 and 10. Which one should we make negative so that when we add, we get a positive answer because we want a positive 1? Well, the smaller number needs to be made negative. When you add these two numbers together, you get 8. But 8 is not what we're looking for. Remember, ding, 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 we want number 1. All right, so 3 does not divide into 20, but 4 does, 5 times. Let's make 4 our negative number. So when we add these, we do get positive 1, which is what we look for. Right, what happens if you go through all this and you can't find, the number that you're looking for? We're going to encounter that a little bit later, and that's called a prime situation. So we'll investigate that. But for what we have right now, we're good to go. Let's slide the numbers minus 4 and positive 5 up here. It looks like the minus is already here, so I need to put the 4 behind it, and I need to put the positive 5 here. You could take this binomial and put it up front, and you could put x plus 5 behind it. It won't matter that way if you move the entire set of parentheses. Check by foiling, and we should get the answer. Okay, depending upon your comfort level, if you want to stop the video and try these 3 examples right here of factoring these quadratic trinomials when a is 1, I might encourage you to do so. Otherwise, I will step you through them. Okay, we have to factor these. Easy case. Let's create a factor sum chart first. That's my suggestion. So I'm gonna make a factor sum chart. Okay, the factors of the product AC and the sum has to equal B. So I'm gonna come over here. A is 1, B is 8, and C is 15. All right, A times C is 15. So the factors of 15 that sum to B, which is 8. Okay, so I start with 1. 1 divides into 15 15 times. Then I could just start going up in the numbers. 2 does not divide into 15, but 3 does 5 times. Then I can move to 4. 4 does not divide into 15. 5 does divide into 15, but I already have it, so I have that set of factors, so I'm done finding all the sets of factors of 15. All right, the sum has to be, the sum has to be positive. So to get a positive 15 when I multiply, both these numbers have to be positive or both negative, I guess they could be, but I'm looking for a positive B value. So I don't have to worry about making an adjustment on the positive negative sign here. 1 plus 15 makes 16. It's not what we want. 3 plus 5 adds to 8, and that is indeed what we want. All right, how do I break this into a multiplication problem? Well, a binomial times a binomial where we have x and x. That will give us x squared. And then we're going to slip in plus 3 and plus 5. You can check by foiling, and we will get back to that problem. Now, could you have put down x plus 5 and then x plus 3? Certainly. Remember the commutative property. It doesn't matter the order you multiply two numbers in, you're going to get the same answer. So it doesn't matter, you know, what order you put these two binomials in. I need factors of the product AC that sum to B. Looks like that's right. Okay, I can get started if I want in creating my answer, x and x. So I need factors of 45, which is just the constant because A is 1. But I need those factors to sum to negative 14. So if I'm multiplying two numbers and getting a positive answer, but summing those two factors, then those factors have to be made negative to sum and get a negative b value. Okay, I'll worry about that in a minute. Let's get all the factors of 45. So 1 in 45. 2 does not go into 45. 3 does, 15 times. 4 is not a factor of 45, but 5 is, and that's 9 times. 6 does not go into 45, 7 doesn't, 8 doesn't, 9 does. We already have it. We just start going back up in this list. Okay, so now let's make both of these factors in each set negative, because a negative times a negative would give a positive 45. But when we add these two numbers, we get negative 46. That's not the set we're looking for. Both negative here to give a positive 45, add together, negative 18. We're getting closer, but that's not the set. Both negative to multiply and give us positive, add these together and we get negative 14. Okay, so this is the set right here. So come over here, x minus 5 and x minus 9. I strongly encourage you to try at least one or two of them. I think the process of foiling again is a good review of multiplying, and plus it just makes you believe that what we did was correct when we broke this problem into a multiplication problem. Okay, I'm going to leave this last one. It will be on the worked out solutions on the PDF that's been attached. So just try that on your own, and if you get stuck, you'll have the worked out solutions. All right, I'm going to go ahead and this is probably a good time for you to stop and take a break if you want to. Otherwise, I'm going to move on to a different type of factoring. All right, we're going to factor by grouping, which means when you hear the word grouping, connect it to 4 terms, if you can. I know there's a lot. You know, a strategy someone has mentioned in the past is that they create note cards for different objectives that we cover. And, well, I'm kind of talking about good strategies here. I might also suggest that if you know that you're going to be watching a video about, say, section 1.5, I would strongly recommend going to your book and just kind of skimming that section. If you skim that section, you'll have some words in your brain that when you hear them and I'm working them out, it just makes more of a connection to what you've seen. Like, I mean, how much of the content will you understand when you read a math section? You know, maybe 25%, 50%. But then when you watch the video of us working out the problems, I just think it sticks better. So just a couple strategies. All right, we're going to factor by grouping. So when we see grouping, think 4 terms. Okay, and consider terms 2 at a time and factor each group of 2. Okay, you're probably going, what's that? We got to see an example. Okay, I see that in this problem, this one, and this one, okay, all 4 of these expressions have, or excuse me, all 3 of these expressions have 4 terms. So that's kind of a red flag for me. When I see an expression and they ask me to factor and it has 4 terms, I'm going to think this method of grouping. All right, so this is what we're going to do. We're going to factor each group of 2. So I'm going to go ahead and write the problem down again. I'm going to write the first 2 terms, and I'm going to put a set of parentheses around them. Okay, then I'm going to write the next two terms. So then I have a minus, okay, right here, and I need that minus right there. And I'm going to group the 2x right here along with this last term. Here's where it gets tricky when you handle this last group. What you're doing is you're taking that negative 2x and you're making it a positive 2x in here. Okay, so you're actually changing the sign. By taking that subtraction sign and leaving it outside here, you're actually changing the sign of negative 2x and making it positive 2x. So what we have to do is when we put this other term down here, we have to also change its sign. Only when there's a subtraction, not an addition. You'll see. So now I'm going to put a plus 10 here. And just think about it for just a minute, okay, before we go into the next step of this method of changing this into a multiplication problem. Okay, if I were to distribute this understood negative 1 inside this parentheses, because that's what I'm supposed to do. When I distribute that negative 1 inside, I'm going to get back to negative 2x, which is what I need. Okay, now when I distribute that negative 1 into positive 10, I'm going to get back to a negative 10, which is what I need. Had I not changed this sign and left it minus, think about what would have happened if I didn't change the sign. You would be multiplying a negative into a negative, and you would have said that that would have been positive, but that wasn't what was presented to us in the original problem. So when there's a subtraction sign and you put a set of parentheses around these last two, you've got to change the sign of everything that's contained within the quantity that follows that subtraction sign. Whew, I know that's a lot. Okay, so we're going to come back and finish this problem. We haven't even finished it. We haven't made it into a binomial times a binomial. Okay, this is not a multiplication problem here. We still have this subtraction. We'll come back and finish it. I want to talk about, let's group these this next problem. So how would we do that? We'd take the first two terms. I put parentheses around it. Now notice that this operation is an addition. So we got a plus 5x. So I'm going to go ahead and put another set of parentheses. Now I'm going to put a 5x in here. I did not change the sign of 5x up here by putting a parenthesis here. So the minus 10 can come down as is. What I'm distributing in is a positive 1. And so when you multiply, you're going to get back to what you had up here. Okay, let's see what happens in this third one when we do the first step for this problem. What's next? Not a plus, but a minus. And you're going to put 6x here. Okay, you can't put plus 4 here, because if you do, when you distribute it in, you're going to get a minus. You've got to also change the sign of the 4. All right, sometimes I kind of like to teach that way, kind of a flow there, because while we're talking about this concept of why do I have to change the sign, it's good to see a couple of examples. All right, now let's get back to changing this into a multiplication problem. We're not done. We group the first two, we group the last two. Next thing we do is we take each set of parentheses, we factor each of these groups of 2. So what's the common factor that comes out of each of these terms? Well, I don't have a number in front, I don't have a coefficient in front here, so let's move on to the variables. X squared will come out of x cubed, and x squared will come out of x squared. So I'm going to put a parenthesis here, just like when we did the GCF on the other page. Okay, x squared times x would give me back to x cubed, plus, from this plus sign, okay, x squared times 5 would result in my getting back to 5x squared. Bring down the minus. I don't need that 1 there, that was for another purpose, but now let's look inside this parenthesis. Do we have a common factor? Yes, 2. When you divide a 2 out of both these terms, you get x plus 5. All right, these problems are contrived. They're made up. They're meant to be such that when you do the factoring, you get a common parenthesis. Okay, not x plus 5 here and x minus 5. These both should be the same sign, the same exact terms with the same sign. Okay, and if you don't have that, then you probably made a mistake in changing one of the signs. It was probably this situation. Is this a multiplication problem? Nope, I haven't factored it yet then. So now what happens, we grouped, we took out a common factor, we have that common factor again, so I'm going to look at this whole group, and I'm going to look at this group. Now these two terms, this is a term, it's made up of a factor and another factor here, so this is a whole term right here, and this is a different term. This is now 2 terms. I'm going to divide out that x plus 5 parenthesis. I'm going to take it out of both of these terms, these groups. So When I divide it out, it means I'm factoring again, so I need a parenthesis. So when I take out x plus 5 from this group, I'm going to have left x squared. When I take out x plus 5 from this group, I've got the minus 2. Notice how we have a binomial times a binomial, okay, and we have a multiplication problem. Yeah, it looks a little different because in this binomial we have a quadratic term, remember second degree, okay? No, it's a little bit strange, but that is our multiplication answer. We did factor, and we factor by grouping. If you get the hang of it, I turn off the video and complete these two. All right, and I'm going to finish up this video. It's going to be long enough by finishing these two problems. And then we'll continue in another video. Okay, I grouped. Now let's factor. X squared will come out of both these terms, leaving x minus 2. I have a plus sign. 5 will come out of both these terms, leaving x minus 2. Do a double check. Yep, same parentheses. So in each of these two new terms, I'm going to take out the parentheses. And when I take out x minus 2, I'm left with x squared and plus 5. Some would probably ask if we were together, they would say, could you like switch these two parentheses? Yeah, you could. You could put the x squared plus 5 up front and the x minus 2 behind. All right, and the last one, looking for common factors. So 3 and 2 don't share a common factor other than 1, so let's move to the variables. Both these terms in this upfront quantity have an x squared. Just be careful. This will be 3x and this will be minus 2. You got the minus. 6 and 4 have a common factor of 2. 2 divides out of 6 3 times, so I have 3x minus 2. Double check that these are the same, because if they're not, you made a mistake. And we have to go back and kind of find out where it's at. Now for these two new terms, I've got that common factor of 3x minus 2. Don't forget to make it a multiplication problem now. That's our objective, to factor. And when I take 3x minus 2 out of this group, I'm left with x squared. And I take it out of this group, I'm left with minus 2. All right, so we looked at several things in this video. We looked at on the front page taking out just a greatest common factor, GCF. Then we actually factored quadratic trinomials, easy case, when a is 1. Okay, and then we actually looked at factoring by grouping. Right, in the next video, we're going to look at factoring trinomials when a is not 1, and we need the idea of factoring by grouping to help us do that more complicated case. So we'll resume in just a little bit.